Let's go over the future value in annuities exercise solutions. For example, the Smiths want to save $40,000 in 2 years for a down payment on a house. If they make monthly deposits into an account paying 12% compounded monthly, what size payments are required to meet their goal? So the future value of an ordinary annuity, S equals big R times 1 plus I to the n minus 1 all over I. So over here, what is S? What is the future value? They want $40,000. Well, what is I? I is your interest rate divided by M, the number of compounds. Your interest rate, 12% is 0.12. Your compounded monthly, so that's 12, and 0.12 divided by 12 is 0.01. And then N, which is M times T, is your number of compounds, 12, times number of years, 2 is 24. So R is what we're looking for. We're looking for that continual payment, that continual deposit. So plug in what we know, 40,000 equals R times 1 plus 0.01 to the 24 minus 1 over 0.01. Do your basic simplification. So we get 1.01 to the 24th minus 1 over 0.1. My suggestion to you is to do the 1.01 to the 24th minus 1, enter, then divide by 0.1. If you try to put this in your calculator in one move, you might forget to put the numerator around in parentheses. When you do that, you get 26.97346485. Divide the 40,000 by that number, and you get R equals 1482.93899. We'll round to dollars and cents, so the Smiths should deposit $1,482.94 into this account every month. And if they continue to do that, then they will be able to save that $40,000 in 2 years for the down payment on the house. Now, how much must be deposited at the beginning of each year into an account that pays 8% compounded annually so that the account will have $24,000 at the end of 5 years? Remember what this is. This is the future value of an annuity due. This means at the beginning here, you get that extra interest payment. So it's this exact same formula here, except we have an additional multiplying by 1 plus I. So let's figure out the information we know. We know the future value we want is 24,000. I, which is R over M, would be the 8%, 0.08, compounded annually divided by 1, or 0.08. And N will be M times T, which is compounded yearly, 1 times 5 years is 5. So plug in all of that. 24,000 equals R, what we're looking for. The 1 plus 0.08, or 1.08 to the MT, to the N right here, 5, minus 1 over 0.08. And then we have this extra interest payment right here because we're doing this at the beginning of each year. Go through this calculation slowly. Do the 1.08 to the 5th minus 1 first, enter. Divide it by the 0.08, enter. And then take that number and multiply it by 1.08, enter. And you get this 6.335929037. Divide 24,000 by that number, and you get 3787.921213 is your R. R is money, so we'll round to dollars and cents. And so we need to put $3,787.92 at the beginning of the year, each year for 5 years, if we want to have $24,000 at the end of the 5 years. All right. Suppose we're going to make payments of $1,000 into an account at the beginning of each quarter. Again, beginning, that extra interest payment, this is going to be an annuity due. And the interest rate is 4.8% compounded quarterly. How long will it take you to have $12,500 in the account? All right, so what do we know? We're going to use this formula here again with the extra 1 plus I. So what do we have? We have S, the future value is 12,500. R, our continual payments or our continual deposits are 1,000. I, which is R over M, is 0.048 divided by 4. Compounded quarterly is 4, which gives us 0.012. And then N, which is M times T. M is 4, but T is what we're looking for. So let's plug that all into the formula. Our future value S, 12,500, is equal to our R, 1,000 times 1.012 to the 4t minus 1 times 0.012 times this extra interest payment of 1.012. First thing I'm going to do is divide both sides, or actually, you know what? I'm going to multiply the 1,000 to the 1.012, and I get 1,012. Then I'll go ahead and divide both sides by 1,012. And when I do, I get 12.35177,866. Remember what I've said before, save your rounding until the very end. Equals 1.012 to the 4t minus 1 over 0.012. I'll get rid of this 0.012 by multiplying both sides by it. And I get 0.14822134439 is equal to 1.012 to the 4t minus 1. Go ahead and add 1 to both sides. And now we have 1.14822134439 is equal to 1.012 to the 4t. The variable we're looking for is in the exponent. To get that down, we're going to need a logarithm. So I went ahead and took the natural log of both sides. Take the natural log of both sides. And now what you're taking the logarithm of is being raised to a power. You can bring that power out front. So now I have the natural log of this 1.1 number is equal to 4 times t times the natural log of 1.012. I'm trying to get t by itself, so I can divide by the 4 and the natural log of 1.012. I urge you to make sure that you put parentheses around this, because if you just do the natural log of 1.1 number divided by 4 times the natural log, without that natural log being in parentheses, it won't divide by it, it'll multiply it by it. So make sure when you do this, you get 2.896702571 as your t. And so we'll round that to approximately 2.9 years. So it'll take about 2.9 years to get that $12,500 you need in this account. That's it for these exercises, and we'll see you next time.